Hello, everyone. So, thank you for being here today, and thank you, Michael, to have accepted to present today for this renovation and resilience presentation. Um, so, yeah, I just want to introduce our sponsor. You're familiar with that. So, Passive House California is a partner with PHN, Passive House Network, and we are also affiliated with International Passive House Association, and then also with the Passive House Institute, obviously. Our gold sponsor is Southern California Edison, and silver sponsor, Small Planet Supply and Earthbound Homes. And we have also plenty of other sponsors, but we need more sponsors. So if you have a company, if you want to give us some sponsorship, please feel free to reach us, and we're gonna add your banner here. I mean your logo here, so you will see all the sponsors. You will be seen as a sponsor of Passive House California.
Hi, everybody. I'm Michael Shea with RDH Building Science. Thanks for having me here today. I'm just coming in to tell you guys about a project that I worked on a couple of years ago. Also, I know Megan Duff is in this call as well. She worked on it as well. It was a big team of people, and it was a really interesting, exciting project for us working on retrofits, which is a really near and dear kind of topic to me because they're just really important. The whole idea being that existing buildings are such a huge component of our building stock. If you ignore them and focus only on new construction, there's only so much of an impact that you can have with kind of the design theories and strategies that encompasses things such as passive house. So this wasn't specifically a passive house project, but there are a lot of principles from passive house that were in play here. I think have a lot of crossover. So go on. So some learning objectives today. This presentation is very specifically focusing on retrofits. One of the things that stands out for retrofits versus new construction is you're working with what's already there. It may or may not have been designed with the intent to accommodate what you're trying to do. So what are existing conditions? What that can complicate it? What existing conditions might make it easier or that are advantage to you? How to engage with installers, contractors, suppliers who may be mostly working with new construction, because that was one of the things that we did for this project was we used products that were already available or were in development that were mainly targeted at new construction. And did do some sensor data to evaluate what the retrofit actually did. So, see how much you can improve the enclosure by doing things like this. And then some of these relative costs or kind of relative efforts specific to retrofits like demolition and abatement. So I already went into, why existing buildings, but, existing buildings are such a huge percentage of the building stock. The majority right now, certainly by year 2050 or something pretty far out, they'll still be at least 50% of your overall building stock. So being able to retrofit them, improve their energy performance and other things like energy performance, thermal comfort, reducing their associated greenhouse gas emissions is just a huge target and really exciting if you can find a way to make it work. So this project was it was funded by a grant from the California Energy Commission, and we worked with partners with Association for Energy Affordability, David Baker Architects, RMI. Drive It was a part of those suppliers who provide some of the panels. And the idea was that you try and prove out a retrofit strategy that can fit as many typologies as possible. Obviously, every building is unique and you need to be able to accommodate those unique features, but to be able to scale up to a larger number of buildings across, just say in California, you want to try and find something that applies to as many as possible. So this project, we focused on retrofit panels and roof panels, or at least that was my focus. There were also mechanical system upgrades. I'm not going to get into those now because my focus was pretty much on those enclosure upgrades. And yeah, the idea is that we do these retrofits very quickly and with as minimum disruption to tenants. And so in some ways succeed with that. Other ways, some things just take longer than you expect, which is what always happens with new things, but that was like the goal of this Realized California project. So I'll just jump right into it. We had 2 demonstration sites. We were lucky enough to be able to install across several buildings. So it's not just one building, 2 different areas. One was in Rich Grove, California, in the Central Valley, and the other one in Corona, California, so pretty close to LA. Both of them are fairly inland, not immediately coastal, and so can get pretty hot. I'll just jump right into what these buildings look like, these existing conditions that we saw. So this Veracruz project, this is the demonstration site that was in the Central Valley. And the base building that we're working with, they have these steep sloped roofs, existing stuccos. Building was built in 1990. These walls did have insulation and but existing single pane windows from that vintage. Inside these attics, it's pretty standard cellulose insulation at the ceiling level, and then you have within these attics, and you have OSB sheathing, and the asphalt shingles for the roof are just immediately above that. Corona, this is a different roof, so this is at the other demonstration site. So just to show the variety of different conditions you'll encounter for ostensibly, these are both low-rise multifamily buildings, but they looked very different. So this one is in Corona, so closer to LA, and this was a low slope roof, but basically flat compared to the other one that we were just looking at. And instead of asphalt shingles, it's a built-up bitumen-based roof. This is a look at the exterior conditions of the walls. So these are existing stucco walls. This is the picture at Corona, but I think that this is probably pretty representative of a lot of existing building stock that you'll see. This was at Corona, which was built in the 60s. Veracruz was built 30 years later in the 90s, but even that was still 40 years later. I would expect this similar kind of deterioration that you see, the finish coming off of the stucco, obvious areas that need patching, that have had experienced deferred maintenance, just big hole at this corner. And I think the big thing that was a huge headache for the team in trying to figure out what to do with was that these were the stucco and the drywall at Corona had asbestos. So you couldn't just rip things out and drill and whatever. You had to do abatement. You had to have a plan for that. You have to have these environmental contractors coming in very specific phases with all the work, not just the enclosure that I'm focusing on here, but also the mechanical electrical upgrades. So that was a major component of what we were looking at from the exterior. Structurally, what do these buildings look like? Not very good. This is at Corona, where we, as a part of our investigation, what we're doing, we're hanging panels onto these buildings. That was the demonstration strategy that we're going for, which adds weight. So we needed to look at what was going on here. And this was just one very short stretch. These, we did a pretty extensive survey along the interior where we removed the bottom stretch of this interior drywall and saw things like, deteriorated framing, corroded shot pins. There's no sheathing on these buildings, so their lateral load resistance was entirely based on diagonal bracing, which may or may not be effective. You look at this isn't doing very much for you. And you have sill plates that are discontinuous. Basically, items like this, in some ways, the project team was like, you almost wish that you wouldn't see it, right? But you can't ignore it, and you have to assume that you need to have a plan to be able to treat these things. And so that was a part of the project that we did, just repairing and making sure that they're at minimum up to what they were supposed to be when they're first constructed. So I just brought this up. I originally had this at the end, but I wanted to point out what we were just talking about, this demolition and abatement and some seismic repairs as a proportion of the overall cost that we're looking at. It's a pretty significant part of it. I would say the abatement portion of it definitely led to a lot of delays and a lot of cost for it. And anybody who's trying to address this kind of this work in a retrofit should treat that seriously. It's a significant portion of your cost. I'm going to go into what solutions that we did then in terms of our enclosure, our retrofits here. So at Veracruz, this is the building with the steep slope roof and insulated walls. Because the walls already had fiberglass insulation within the studs, our focus was less on doing a panelized insulation retrofit at the walls and focused on providing the panels at a roof. So a panelized solution for the roof. We also replaced the windows to dual pane windows, vinyl windows, and added head flashing to kind of increase the durability aspect with response to rain. The general strategy for the overcladding, providing these retrofit panels, was we took that existing shingle roofing, we stripped it all off, we took it down to the roof sheathing, we installed the underlayment, which is essentially a roofing membrane directly onto that sheathing, and then covered it up with the insulated metal panels. So the metal panels both protected your roof underlayment, the primary roofing that's keeping the water out, and also provided that insulation value. Part of what we were doing here was the kinds of insulated metal panels that we installed on these roofs at this Veracruz project. These were available. There was no product development that needed for this. These were used quite typically in things like refrigerated warehouses. So our idea was that, hey, these insulated metal panels could be used in this kind of retrofit. There's already people who install it. This should be fairly straightforward. The thing was, you have some adaptations you have to do when you're taking a commercial new construction product to the retrofits. An example is I have this little section where we're going through shop drawings with the installers where their idea was they're used to installing these panels direct to metal deck for a refrigerated warehouse. But because we're dealing with an existing building, they assumed that they could just fasten right into it and use the sheathing for uplift resistance for these panels. The wind's blowing, it's pulling it up. We needed to have them demonstrate to us that, hey, calculate what your actual wind uplift is with these panels. Can you just fasten into the sheathing? And the answer was no, you could not. And that was a step that we had to ask them and make sure that they covered. And so what we ended up doing was, you'll see here in this kind of section, they needed to install hat channels. That's these channels here in this photo to be able to fasten into those attic rafters. And that is what the insulated metal panels fasten to. So this is an example of a thing that the new construction installers assumed that they could do it a certain way. We needed to adapt to what the existing condition was. And this is what it looked like when we were installing those metal panels, those insulated metal panels on the roof. The idea is very straightforward. Take off the shingles, add this underlayment, hat channels, go in and fasten it in. And once it was in, the installation was pretty quick. But there was a lot of groundwork that needed to happen to lead to this point. Something else that we also did at Veracruz to improve the energy performance was we actually did some additional air sealing within the attic level. And I don't know if anybody's worked with or seen Aero Barrier, but it's basically, there's a product called Aero Seal that's used for ductwork, for sealing existing ducts or even new construction, where they aerosolize a sealant into ductwork, and then that closes up a lot of gaps. This has been adapted to more of a retrofit scenario where they actually put these aerosolized sprayers of the sealant into the attic space, and then they use blower doors to depressurize the space below to pull sealant through, and the sealant then accumulates and seals up cracks at the ceiling level. Obviously, you need to do things like protect finishes and cover up things that you don't want gunked up with sealant, but the good thing is that the aerosolization of the sealant happens at this attic space, and that's what we used. And so we do have some air leakage data that I'll show of kind of what that looked like before and after doing the Aero Barrier, versus a traditional approach, which we also did on one of the demonstration buildings, which was instead of doing this aerosolized sealant and then depressurization method, we had somebody go in and said, hey, at your roof to wall interface or other areas, seal it up with manually seal it, essentially, kind of what people would do now. So I'll jump to the other building for Corona del Rey. This is the one in SoCal. And this is a case where this building was built in the 60s. There's no insulation, there's no sheathing. It's just like what you see as the exterior stucco here is just chicken wire struck, put out over open stud bays, and you just install stucco onto it. That's what we had. And so because there are existing uninsulated walls, that made it more of an attractive, kind of bigger impact to install insulated wall panels onto this building. We did not do the same roof panels as we did in the other project because this was that very low slope, almost basically flat roof. If you were to install panels on this, it becomes very complicated about water getting through, where does the water drain out? So in this case, it made more sense for us to go with kind of more of a typical removing the existing roofing and just install and just re-roof the building, but with insulation this time, because this roof was also uninsulated. Similar to the other project, to the other demonstration site, we took this opportunity to replace the windows because windows are a huge component of your thermal and air barrier for any building. So this is what we did for the wall retrofit at Corona del Rey. You'll see that we had these existing porte cochere structures on the building. Part of the reason why we chose these demonstration sites was these structures weren't part of they weren't a structural part of the building. They could be removed, and we needed to do that because to try and demonstrate out this strategy of using these overclad retrofits, you need as simple of a building, basically a shoebox, as flat as possible, not a lot of ins and outs, just to see what this would be. So here, what we've done is this is a different color from before, but this is basically a new elastomeric air and water barrier that we applied to the surface of the existing stucco. This did involve repairing the stucco because you remember that photo from earlier. It had all sorts of patches where the finishes are cracking off and things like that. We had to repair those first and abate it as we were doing that. But we applied the new air and water barrier, removed these windows. The new windows are starting to come into place on this first floor. This is at a time when we were doing some blower door testing as well. But this is kind of an idea of how simple we went for to be able to do this retrofit. This is the general, this is the schematic look at the types of panels that we installed on it. So basically this green here is that air and water barrier that we applied on the existing stucco, and then we installed these rails that we hung the panels on. The panels that we had on the upper floor, we did try and prove out a strategy of installing windows into the panels and then hanging those panels onto the building. Whereas in this bottom floor, we used a strategy of installing the windows first and then the panels separate, just to kind of understand the intensity of what we needed for labor and logistics, and also the weight of the panels, because panels that have windows already in them are going to have to be structurally supported and will look different. So we have measured performance data from both of these demonstration sites. One of the interesting ones to me is at Veracruz, we did install temperature sensors inside this attic. So temperature and moisture, humidity, we had a lot of data here, but focusing on just what is the dry bulb temperature inside this attic before and after the retrofit. So this red line, the orange line here, is the temperature inside the attics before we retrofitted. It ranges from, and just in the hottest parts of the year, between July and August. September is probably pretty hot too, but we caught that August portion. It ranges between, in the 50s to over 135 degrees inside that attic. After we did the retrofit, this is the blue line here, we significantly compressed the temperature swings inside that attic. It went, ranged between 75 and 85 degrees, maybe into 90. But it's a huge difference from before and after, and kind of proves that, it goes to figure that you install insulation on something and you're going to have not crazy temperature swings. That's not That's not crazy science or technology, but it proves out, but it's all about the process that we got through. You know, these products aren't usually used in this scenario. We were able to use them successfully. Air leakage. So I'll actually go to Corona first because I was actually very curious. So this is the one where I was talking about that aero barrier approach, where we aerosolized inside the attic space and then drew down and compared that to a more conventional manually applied sealant approach. So the conventional approach is on the left. Green is before, yellow is after, and then on the right is the air leakage just through that sealing space before and after using the aero barrier approach. And it's a big change. It's a big reduction. And on average, the reduction with the manual air sealing technique was about 14% versus 50+% with the aero barrier. It's a really encouraging result. I would say that for Veracruz as a demonstration project, and Corona as well, but you know, the panelization and everything has costs associated with it. I would say that I wish I had a specific number for how much it costs to do the aero barrier, but I guarantee you it was a much lesser degree, order of magnitude cost compared to installing additional overclad panels on top of the building. So this approach of doing this attic air sealing, I think, is worth looking at for a lot of other retrofits in the future. I think is very encouraging. This is Corona del Rey. This is the project where we installed the wall panels and where we had to fix the stucco, apply a new air and water barrier onto the face of the existing stucco, and then install panels on top of it. We were able to measure the air leakage before the retrofit, and then after the retrofit, we did a mid-construction air leakage test as well, just to identify areas that they needed to seal up. But we were able to achieve a really big reduction, about 1 CFM per square foot at 75 pascals. I at one point had this in ACH. I don't remember what it is right now. I can follow up later with what that is, but it's a significant reduction from 0.956 CFM per square foot to 0.29, almost 1/3. And the thing that I really love about this is that this red line is California Title 24 Energy Code requirements for a new construction building. So we took a building that was built in the 1960s, we did this retrofit, and we achieved an air leakage target that was better than new construction. So a building built in 2025 is held to a standard that is still higher than what we were actually able to we were able to beat that, which I thought was really impressive and very validating of the strategy to me. And just looking at some pictures of it before and after the retrofit, so this is Veracruz on the left, before and after. You know, it's a lot of the refreshing of it included. So we have these new windows and then this new elastomeric paint that we applied to the existing stucco, so increasing air tightness that way as well. I think it looks pretty good. You can barely, you can see these roof panels, these insulated metal panels on the roof if you kind of really look at them, but it looks like a normal building. We didn't do anything really crazy to it, and we're able to achieve a good result. Similar for Corona, this is where we did the wall panels, and pretty happy about how it turned out. So my conclusions from doing these retrofit demonstrations is that they're technically feasible, but we ran into definitely some significant logistical and financial challenges. It cost a lot more than we wanted to do, and which is why I was kind of pointing out that there's a whole mix of strategies that we did. We were fixing the existing walls, bringing them up to kind of more better standard. We installed these panels, we installed new windows, we did the air sealing of the attic. Things like the air sealing of the attic, I think, were very, very good targets for further retrofit efforts in the future. The idea was that we would be able to work with a single manufacturer who has the panels that they already have in their stable, the air barrier that they do, and they're able to just single source basically a retrofit, the materials and the kind of the expertise to scale this up. what we found in this demonstration project is that wasn't quite ready for that scaling. Technically, the air and water barrier and the wall panels were by one supplier, and they had the capability, kind of the pieces in place to be able to do it, but it requires a lot of intense coordination that kind of currently doesn't really exist. And so we went through a lot of challenges with that on this project. And just working with the installers for these products, they're used to installing things a certain way. It's different with a retrofit. Some open questions that I don't have immediate answers to, but need to be considered for anybody doing this. I'd love to say, how do you deal with asbestos? You just don't work on a building with asbestos. Unfortunately, we didn't really have regulations banning the use of asbestos in California until 1976. I think it's 1976. You still had people with stocked material with asbestos that was used up until mid 1980s. So, you could, just say we'll only work with something that was installed late, that was constructed later, but to be able to scale up and install, have that impact for all these older buildings they're not going anywhere, they're still there. How do you have a retrofit strategy that minimizes what you need to do? It's very targeted, or it's a very simple and straightforward way to deal with it, to deal with that demolition abatement piece of that chart of the costs that we were looking at before. How do you deal with structural damage? And I say that can't be ignored, meaning you open it up. For me as an engineer, you have an ethical obligation. Once you know something's wrong, you can't just, as much as you like to, just close your eyes and just pretend that it's not there. You need to deal with it. You need to have a strategy for it. So have that strategy up front. What we ended up having was, we had our structural engineer produce some details of saying, hey, if the studs look like this, install this, this strapping in this way and this fastening pattern. There are going to be conditions that need some additional oversight, but we can cover a lot of it. How do you incorporate methods that are familiar to installers? Use something that they're used to seeing in Home Depot and Lowe's, and they can go and get, maybe these panels that was one thing where a residential installer contractor doesn't usually see this. You'll have to teach them, and there's going to be some slowdown is associated with it. So maybe the next kind of idea with retrofits is you use something else. Honestly, right now, if someone were to say, hey, I want to use overclad retrofit panels on all these buildings, I would say, let's talk. We need to talk about this, and not say like, oh yeah, it's great. It does work. We have the sensor data to prove it, but there's some processes and that need to be addressed. And I added this in at the very end. How to retrofit to improve resistance to fire. That's a big topic right now, especially with the most recent fires in Southern California, and but also like not just this year, but over the past decade. We've seen a lot of major ones. And the thing that's interesting to me is that some of the things that we did as a part of this retrofit, for example, where we installed the metal roof panels, we did things like we sealed up so it wasn't a vented roof anymore. So that closed off the path for future embers in a wildfire scenario. The roofing that we installed was Class A roofing, has less combustibility. Same with the wall panels that we installed. These are, things that we were focused on. We did it from the perspective of energy efficiency and thermal comfort and things like that. But it wasn't a trade-off that we had to do for hardening these homes against fire. It kind of enhanced their value beyond that as well. So something to consider and maybe incorporate further into any further retrofits that we're doing. So yeah, that's what that was the main series of slides that I had on this project, but I would happy to take any questions that people have. I have a lot more slides of details and other investigation photos that we have, but I want to open it up for any questions that people have and dive into this. I see Debbie.
Hey, Michael. Hold on. I'm just trying to get everything working here.
No
Hey, so I'm here in San Diego. So hey, and was trying to put a project together in 2023 at the Navy to do something like this, to do a panelized exterior retrofit. on their buildings because they don't have any air conditioning, but it gets really hot.
Yeah.
And so I just wondered, did you have to relocate residents? Did you do a phase thing where you did this building, the next building? I know the two, like doing the roof was probably not something you'd have to relocate everybody, but it looks like the walls, windows, and that looked like you probably had to empty the units out, huh?
Yeah,
Thank you.
so basically it was a different approach for the two projects. The idea was that we'd be able to do it with the residents in there, but so I'll just pull it up. So for the Veracruz project, the residents stayed in there. There was some disruption when we had to go in and do some work with the HVAC upgrades. We added, they didn't have cooling before, they got cooling after this retrofit. But we were able to do this overclad without having to move anybody out. The wall panel retrofit, we worked with the property owner because they had it was like kind of a whole complex. And so that whole building was actually unoccupied at the time. The idea was that we'd be able to install it very quickly within the period of, couple weeks at most. That was the idea. It didn't go that fast. And so even so at the minimum, probably people would have had to move out, if only to do some of those like repairs that we did structurally. But yeah, it was, I would say the best thing was to have it phase such that it would have been impossible if it weren't unoccupied at that point in time.
So it was only one, like in a whole complex. You just kind of did a fourplex or something within the.
Yeah, so what we had was so at Corona where we did the wall retrofit, it was two buildings across this entire area. These were all similar buildings. And so we did some slight differences between the two, but it was a really useful comparison to the existing kind of conditions that we have there. But yeah, these were fourplexes, so 4 units to one building. Yeah.
Great. Thank you.
Yep. Well, next question from Ephraim. Sorry if I said your name wrong.
That's right. Ephraim. What kind of steps did you take to mitigate moisture inside the buildings after you sort of sealed everything up tighter than it was prior?
Yeah, so what we did was that was part of our investigation for certainly the Veracruz project because we sealed off the existing vents in the attic. And so the idea was that we had brought the attic fully into the thermal envelope and we installed relative humidity sensors, and we had done some hydrothermal modeling of that space to verify, and we checked with the sensor data that it was already very bone dry in that attic beforehand because it was vented hot climate. And after we had sealed it up and done this insulated metal panels, you no longer have the condensation risk, because even if you have moist air that gets into that attic, it contacts the sheathing. That sheathing is now insulated is like 6 to 8 inches of insulation of polyiso insulation. So we made it an unvented attic, but had significantly reduced that condensation risk. Plus, we did that air sealing so that there's even less chance of moisture-laden air coming through that ceiling into the attic space. So we kind of had dealt with it in kind of 2 different ways.
Okay, cool.
Megan?
Yeah, I was wondering, I may have missed it, and I apologize if I did, but are these buildings on slab, or did they have crawl space, and was the crawl space adequate to get in there and put something in the crawl space area to make it more sealed?
Yeah, both projects were slab on grade, so there was no crawl space. I think that's a really great question of if you have a building over with a crawl space, how do you deal with air leakage through the crawl space up through the floorboards of the building, through the floor of the building? And I would say that I think that's a really interesting, maybe alternate application of something like the air barrier, though how they would do that, I think they've proved it out and done it a couple times in attics. I think crawl space is something that could use a similar strategy, but it would need to look different. But I think that's a really great point. That is definitely in buildings with a crawl space, another avenue for air leakage that you can consider. Debbie?
I just noticed on one of your other slides that you used I'm going to say it wrong, the EFICA or the EFOCAs. Have you been charting their performance? I know I really like those in 2023 myself, but I keep hearing, some stories that maybe they're not working as well. Their performance is just not meeting what you expect, but how has that been? Have you been able to check in with those folks since those were installed? Thank you.
Yeah, I am actually not, I wasn't very closely part of the mechanical side of the most that I kind of was most intensely involved in was how to design the penetration details for the vents for these, but I'm not really sure about the measured performance. We do have that data that is under the purview of some other people. I was just checking the chat to see if Megan is still on here, but I think she had to go. She would be the best person to ask about that, and I'm curious. I think that's a good question. And I will look into that on my end as well, because
And you did say you didn't do the mechanicals, that you were really on the envelope, but
that's
yeah,
right.
I just happened to see that. Sorry, I forgot.
No problem. I mean, I'm curious myself. I would
love for them to work.
Yeah, everything's like a really great concept, and being able to measure and see exactly what's going on is key, especially if you're hopefully trying to recreate the things that were successful.
Thank you.
Thank you.
You spoke about measuring. Which system did you use to monitor temperature and humidity?
So I use sensors by a company called SMT. They're a Canadian company, and they have research grade sensors for relative humidity, moisture content of wood, just air, dry bulb temperature, and relative humidity. So we used those, and it installed those into the spaces. I have some photos, maybe not in the slideshow of the installation of those, but things like measuring the moisture content within studs. We actually also had, I don't have graphs of that data, but we also installed the moisture and temperature data inside the walls at Corona, where we had the wall retrofit. And I don't have that data fully put together right now, but that is an ongoing data collection process for that. I do think that if I were to do, and actually I have another future retrofit project where I'm aiming to do a similar measurement and verification, and I would say that doing something that's focused mostly on just the temperature and relative humidity and extrapolating from that to make some inferred guesses on moisture content is probably more practical to do, because a lot of these we had to wire these were hardwired sensors, but you still had to have Wi-Fi and all that for data collection. It's pretty complicated, and I'm happy to jump into. I have a lot of documentation of what we installed and how, and kind of where it was painful for data collection, but it was very valuable data, so I'm glad that we did it.
Good, thank you. There was another question in the chat from Ian. Was the gap between the insulation and the grace an issue in terms of efficiency? How large was this gap between these two surfaces? So, and was that actually ventilated? That would be...
Yeah. Let me see. Let me pull up the slide. So for the roof panels, what was the gap had? I'm just going to pull up that section just because it's the relative one. It's the relevant one. There is a pretty decent gap here. I don't remember exactly what it was, but it was probably something between 1/2 inch and 1 inch gap. What we did have was we had air baffles and sealant at where this meets the roof edge. And now what we used was reticulated foam. So the reticulated foam is an air baffle that kind of mitigates to a significant amount wind washing underneath those panels, but still allows water at this plane to drain out at the roof edge, because that's what the roof is for. We're assuming water, not very much water is going to get underneath the panel, but you always assume that it will, and for it to drain out, it has a reticulated foam in that gap. At the wall panels in Corona, we used a similar strategy. Now that one was much more difficult to manage because, I mean, I'll just pull up the photo again, but this is the substrate that we're working with. It's not very flat. You know, across one whole elevation of the building, the in and out from one end of the building to not even that far away could have been as much as an inch and a half out of plane. So that had its own installation challenges for hanging the panels, but we did incorporate as a part of our design air baffles and sealing at the edges of panels, obviously still allowing for drainage. So that's that balance of handling moisture versus reducing wind washing. And so we reduced as much as possible, you know, pressure gradients to allow air to go in behind the panels and, you know, reduce the effective R value, but still allowing for drainage behind them because we're assuming that water at some point, you know, right now it probably not, but sealant joints do fail. They do get old, they are a maintenance item. So 10, 20 years down the line, water getting through them, if they're not maintained, which I would assume that they're not, honestly, that's the unfortunate reality. Water getting behind can still drain out and doesn't become what you've done doesn't make it more of a liability in the future.
We are running low on time. I did put a link in the chat for the AIA and PHI credits that are available. If you commented a question and you're able to unmute, go ahead and chime in, but I just want you all to know we've got about 5 more minutes.
I had a question.
Sure.
Was the air leakage through the replacement windows given any consideration?
So what we did was, for this building specifically, we did account for, or we did measure air leakage through the windows because what we did was a whole building air leakage test. Let me see, it's just a photo of me doing blower doors, but it's basically, we installed 4 blower doors. Yeah, here we go. This is me running a whole beer. So all of these 4 units are connected. I installed blower doors in all 4 and controlled them, you know, pressurized them to the same degree so that we are including air leakage through the windows. It's everything.
What I more meant was when you picked the windows, did you give consideration to how leaky they would be?
That we had recommended certain performance standards for the windows to be installed, but ultimately, from a budget perspective and also what the contractor was able to procure or their typical supply channels was not, you know, it wasn't something that was really AMA certified. It was whatever they got from Home Depot. And so that's where, unfortunately, we can only have so much control on what's happening within the window, but what we did have control over was the interface detailing of the window to the wall. And we definitely made sure that we did the detailing as well as possible to account for that. I have some of the window details we can pull up if we want, but we did account for trying to make sure that we had continuity of the primary air barrier at these windows.
Thank you.
Yep.
Did you consider other roof panels before you decided to go for the metal ones?
The whole team went through a long exercise on comparing the wall panels, lots of different materials for the wall panels we looked at. We looked at cork, we looked at, you know, pre-built, you know, metal framed walls. For the roof panels, I think this was a little bit before my involvement in the project, but I think there was a lot less conversation around those. And I think they kind of zeroed in a little more directly on using these existing kind of refrigerated warehouse panels that were already available. I think part of it is the advantage to using these is they're polyiso insulation with the sheet metal and is very light. And that's another factor that was in this project was as light as you can go is what you had to do. You know, we would have loved to use things like mineral wool or cork for the wall insulation, for example, but it just didn't pencil out in terms of added weight. And I have a whole bunch of slides on what we had to figure out for added weight to the building, seismic, you know, considerations for these, especially considering the existing conditions of these. So, yeah.
There was one question if you work only locally in California.
So I'm located in San Diego, but RDH has offices throughout, basically nationwide. So East Coast, Central, West Coast, up and down the West Coast. So If you have any questions on a specific project, we do kind of nationwide, so definitely reach out to me if you want to talk about a specific project where we might be able to help out.
That's so much awesome information you just shared. We have a couple of things to show you. Cyril will have to share the screen, but I thank you so much, Michael. This was fabulous.
Yeah, it's my pleasure. Thanks for everybody for joining and listening and asking questions.
Yes, definitely. Thank you, Michael, for this awesome presentation. I learned a lot. I mean, I'm not the only one, I'm guessing. So just, yeah, at the end, we just present this as a call to action. That means that you learn a lot, we learn a lot today. And the goal is to make sure that you can support Passive House California by joining the Passive House California as a member. If you're not, sign up for the newsletter. We have individual and organization memberships to make sure that you can join us. We also accept obviously sponsors, and we can also we greatly appreciate if you can volunteer to be part of a community and propose your help into some tasks that we have. You can have every single information on our website, and you can write to us at info@passivehousecad.org. And obviously, today we learn here. We are in the middle of this slide, but yeah, we can share the information and enlighten people around us. That's all I wanted to say today. Thank you very much, everyone.